Colder than deep space, a chip the size of a fingernail is attempting something physics has resisted for decades. It's trying to translate a quantum secret without ever reading it. But there was a problem that had stumped physics for years. Superconducting quantum computers speak in microwave whispers. The entire global internet speaks in pulses of light. These languages are deeply incompatible. Think of it like an interpreter who speaks both languages perfectly, but can only whisper while thermal noise screams all around them. Converting the signal the wrong way destroys the quantum state entirely. For years, thermal vibration always won. Every wire entering the refrigerator smuggled in heat and noise, the quantum equivalent of carrying a lit torch into Fort Knox. The qubit was an island with no bridge. Here's what most people don't realize. By 2025, leading labs have demonstrated transduction efficiencies exceeding 10 to the -4 photons per phonon, a meaningful threshold. And tracked government funding now exceeds $2.1 billion targeting this class of technology. Progress accelerated because of foundational work done around 2010 to 2014 in Pasadena. Oskar Painter's group at Caltech helped establish that a nanoscale hole pattern could couple both a photon and a phonon in the same structure. That theoretical and experimental foundation became a critical building block. But making it work at millikelvin temperatures was its own war. At JILA in Boulder, physicist Konrad Lehnert's group watched resonators crack, piezoelectric films delaminate, efficiency numbers stay maddeningly low, and kept rebuilding for over a decade. And the stakes kept rising far beyond any laboratory. The encryption protecting your bank account, your medical records, every private message you've sent, it rests on math a networked quantum computer could potentially threaten. Governments already know this. Meanwhile, researchers are using machine learning to predict which crystal geometries may work best before anyone fabricates them. If distributed quantum networks do mature, pharmaceutical companies hope the same platforms could compress drug discovery timelines significantly. Behind the scenes, the geopolitical race has already hardened. Patent filings in this field are growing at an estimated 47% per year. Chinese applicants now represent 35 to 38% of new filings, up from around 28% in 2020. A small number of companies in Finland and the UK currently dominate dilution refrigerator manufacturing. In 5 to 10 years, if current trajectories hold and key engineering hurdles are cleared, the first transducer modules could potentially link multiple refrigerator units. Not a quantum internet, but something like what ARPANET's first 2 connected nodes represented in 1969. A possible hinge of history if it works. Full research, caveats, and sources at KPsphere.com. Subscribe. We find advances like this every single day.